Next is Alex, who will be talking about assessments of physiology and cognition in hybrid reality environments. So Alex, are you online?
Yes.
Alrighty, if you want to take control of the screen and share your charts, there you go.
All right. Good morning, everyone. I am Alex Baughman. I'm a human performance engineer within the Human Health and Performance Directorate here at JSC. And I'm going to talk to you guys about a test bed we call APACHE, also known as, or defined as the assessments of physiology and cognition in hybrid reality environments. So why do we have APACHE? It really kind of boils down to just spacesuit opportunities, and suited testing is very limited and expensive. And there's also just kind of other limitations that we can't necessarily integrate a lot of our different sensors and some of the metrics we want to collect, particularly within the cognitive domain. They're just a little bit harder to integrate with the spacesuit and collect all of the different research or answer all the different research questions that we're trying to answer. So it really kind of just boils down to a lot of the questions that our lab is trying to answer. You don't necessarily need spacesuit testing, at least not initially. So the goal of APACHE is really to create a physically and cognitively realistic planetary EVA simulation environment, emphasis on the planetary EVA simulations. So we don't really focus on any microgravity or space station simulations. And we do this through a combination of virtual reality, physical reality, and then it kind of forms this combination that we call hybrid reality. Others may know it as mixed reality, but we do have right now a couple of different use cases for it in terms of just general human research, in terms of CO2, walkback studies. We also provide different EVA content for analogs. So crew will stay in long duration habitat analogs, and we'll provide some of the EVA content and performance measures that the crew will perform during their stays. And really a big driver for APACHE is this development of some of the informatics and decision support systems, specifically as we as like an agency and just humanity start to transition to some of these planetary explorations, specifically Mars, where the communication delays are really limiting and you don't really get some of that real-time operational support that you'll get on the space station and maybe even the moon. So we really are starting to transition more into an autonomous crew, a more self-dependent crew. So that's kind of what a lot of this research is trying to support the development of those informatics and some of the decision support technologies. So as you can see here, probably the big thing that's unique to APACHE is our sandbox. So we have about 20 by 15 foot play space that's filled about a couple inches of lunar regolith simulant. It's really just golf bunker sand, but I'm told that the grain size is the grain particulate size is comparable to lunar regolith. So we have our little sandbox there. We also use the Vive Pro I right now. I think we're looking to upgrade to the Pro I2s this year, but currently it's just the first generation there, particularly because of that built-in eye tracking and some of the eye tracking functions that Leah was showing in the earlier presentation. And then we also, on the back side, you can sort of see a treadmill. So this is a self-powered treadmill that the subjects can use, which really enables us to some of these longer traverses in VR. It kind of allows us to keep the same room scale VR environment, but it allows you to traverse these kilometer distances that we are expecting crew to do on these exploration EVAs. And then also picture on the right there are some of our hybrid reality elements that you also saw in the previous presentation, but we do have basically these physical assets. They're wired up to a microcontroller and fed back to a server and back into the simulation. So as you see the different physical state changes to these items, you can also see that relayed in the virtual environment. So really just kind of increases the immersion factor there, and also a little bit of the physical demands that you might see, particularly with the hands. So then also just bring it back to just physical and cognitive demands. In terms of like manipulation, we do have a weighted suit that we can use to distribute different loads across the subject. And then also that treadmill that I mentioned, it's self-powered, but you can also change the resistance setting of that to essentially manipulate how hard or easy it is to walk on that treadmill. So those are different ways that we can manipulate the physical demands of our subjects. And then in terms of cognitively, we just have a bunch of kind of embedded tasks that we can add on top of the main EVA procedures. So right now, these are still kind of more developmental, and we're just in the process of testing and validating these. But really, it just kind of comes back to a lot of just heads-up display, a lot of the spacesuit system monitoring and timeline monitoring, as well as a few just reaction and response times that we'll collect. Looks like, let me play the video. It'll play. That's unfortunate. These videos I thought were set to autoplay, maybe. I guess I'm trying to think because these videos are kind of interesting. Not quite sure. Let me.
Do you have them on your hard drive that you can just play them directly on a video player?
Let's see. I might have some. Sorry, this was shot on an iPhone vertically. But here you can just sort of see the video that we're trying to show. The general layout of Apache is that we use that two-player system that Frank was talking about earlier with the Exos Mars environment. Also Buendia has developed, but we have a two-crew system, so EV1 and 2, and then we also have an intravehicular crew member, so essentially the crew that would be inside of the habitat acting as your mission control. You'll sort of see here at the end of the video, they have their own task station with the various timeline execution tools that we use to sort of to do that timeline tracking and relay the different procedures to the crew through the headsets. Let me get back to this. So yeah, we got the two-player. What you just saw was the Martian environment there. We also do have a lunar environment centered around the Shackleton crater. The Mars environment is built on Unreal Engine 5, while the lunar one is currently still on Unreal 4. So we're looking to upgrade that later this year. I did mention the intravehicular activities, so we have those built in as well, just to monitor some of the different cognitive demands that we ask of our crew members inside the habitat as well. And then right now we have a few select tasks for the crew members to complete, namely just some geology and generic scientific experimental payloads. But we are right now really ramping up a lot of the content development, both internally and then also through a crowdsourcing campaign, which I'll get to in a little bit, just to help develop a lot more content for the simulations. So here's just some more images of the space, the Apache high bay space, and just kind of general layout. One thing I actually did forget to mention, though, we do just recently acquired the Infinidec treadmill. So for those who are familiar, it is a commercial product, an omnidirectional treadmill designed for virtual reality. So you can stand on this treadmill and it will walk in any it'll let you walk in any direction that you want. So we're currently also just in the process of integrating that into our sims as well. So just to look at just a high level of some of the research going on within Apache, we've already completed a couple of studies, namely with our passive treadmill and then some of the physical workload testing. But we're also kind of still in the process of going through some of the cognitive workload, just the development and testing of those. And then the weighted suit testing, we still have not quite got to. We'll get to that later this year, looking at basically titrating different weighted loads to the subject to sort of match the physical workloads we would expect in a spacesuit. And then some of the bigger concepts more down the road is this PERSAIDS, which is a personalized EVA informatics decision support system. So that's kind of what APACHE is really boiling down to, is providing this system that can basically predict the crew state as well as make operational decisions based on that crew state and whether they need to increase or decrease future task loads. I'll just get into these since I know we'll talk about them again. Videos and notes. Apologize. So you have a lot of videos. I guess since this was a past one, I'll just continue. I think I have the videos of other ones pulled up. But this was basically a study just really evaluating and kicking off APACHE and the passive treadmill, looking at some of the different cognitive metrics, some of those embedded tasks that I mentioned earlier, particularly with the heads-up display and some of the system response times. So just looking at different ways we can actively measure the cognitive workload through some of these embedded tasks without like probing them through like traditional measures such as subjective questionnaires. I think I have a video of this to share. So this is a study that is in partnership with the Fatigue Countermeasures Laboratory at NASA Ames. So this is really looking at the cognitive demands and some of the embedded tasks that we can include in our simulations. So right now, this is just a subject going through we're just deploying a central like science station and a couple of payloads that need to communicate with that central module. So really just it's a good perspective to see APACHE, how it's used in the sandbox, but then also you'll see some of the heads-up display, and we do include different performance metrics through these tasks. So they have to essentially orient the payload in a particular orientation, and then we'll record those performance metrics at the end. So a lot of the focus within our lab is taking some of the assets that Frank's team has developed and then sort of adding on these different performance metrics to include in our simulations so we can better estimate those performance decrements or impacts based off of various conceptual or operational concepts. So let me get back into the slides. Let's see, so subject testing, yeah, so we are actually going to start testing, going through different subjects this summer. Basic idea of this study is that they go through this payload deploy task. One condition, just the basic payload deploy, and then we have our traditional cognitive measures, including just the various questionnaires that we'll ask. And then our second condition is the same procedure, but now some of those embedded tasks. And just comparing those, the embedded tasks that we've developed that are unique to APACHE, essentially validating those. So here we have this is an let me just talk through the study first, maybe. So here's another human research funded study. It's through the Human Research Program. And I guess the main purpose of this is to just assess the physical and cognitive performance impacts of a subject going through a 1-hour contingency walkback. So this is essentially looking at one of the worst case scenarios. You are basically at your farthest point from the lander, you have a suit leak, now you have an hour to get back to the lander. You essentially have to get back in a certain amount of time, but also not overload your spacesuit CO2 capacity, scrubbing capacity. So that's what this study is really looking at, is the exposures to different CO2 limits and the performance impacts that it may cause based off these CO2. So we have a bunch of different physical measures that we'll be collecting, including heart rate, metabolic rate, various pulse oximetry and transcutaneous CO2 measurements. as well as the CO2, or as well as the cognitive measurements that I've been talking about prior. Let me see if I can pull up this video as well. Yes. Okay, then I will maybe skip ahead. Essentially, this is just showing one of the cognitive tests. So this is the digit symbol substitution test. It's actually a cognitive test we ask our astronauts on board the space station to complete as part of a larger cognitive test battery. So essentially, it's just showing that in operation during the CO2 walkback.
I think you have a little more than 4 minutes. So you started at, I believe, about 9:55 or so.
Yeah,
and I have you listed at 30 minutes. So you still have a 10 minutes or a little bit more.
Okay, yeah, I'll try to plow through, get by some of these technical difficulties. So this is our physical workload validation. So we've already kind of completed some baseline workload characterizations on our passive treadmill and made some comparisons to various other planetary analogs. Namely, we have a rock yard here at JSC that we kind of use to compare against. And then we, as like a follow-on to this study, we do have a custom weighted suit that I have mentioned, and essentially just looking at that and the different configurations of that to essentially match the workloads we experience in the Apache environment to what we see in some of the suited testing, namely Argos, which is a gravity offload system we have here at JSC. So we can get suited testing in the various gravity offloads that we would expect. So this was just some of the preliminary data from that. Mainly the main takeaways from this is that the passive treadmill really was ineffective at manipulating the workload. We believe is due to the self-paced nature. So we are looking at more of the weighted suit now to attempt to titrate some of these workloads to better match the workloads we would expect to see. So this is probably one of our newer projects. It's a really cool project we've got going on too as well within our lab. We call it the Hybrid Spacesuit Simulator. I will share the video in a second, but essentially you see we have a subject here using this essentially a low-cost, low-overhead just spacesuit mock-up that we just recently built in our lab, just to sort of help with making the subject feel like they're in a spacesuit without actually getting the whole overhead of suited testing. So with this, we can include all of our different biometric sensors that we would like to include in a lot of the different suited testing and are trying to integrate. But this just makes it a little bit easier research tool for us that we can use within Apache. And then you also see here a little bit of the integration with the Infinideck. If I have that. Maybe not. Hopefully we can share these slides with the group afterwards, because I guess they have the videos embedded. So maybe that's what's causing the issues. But going back, again, this is another study we are supporting based off of the Exos system that Frank was showing a little bit earlier. But this is supporting a year-long mission in a Martian analog. So we have been tasked to provide the EVA content for the crew during this year-long analog, and then also provide different performance metrics to characterize that performance or the crew performance throughout their stay. So we do use that 2-player, the Mars environment, and then we have a bunch of different EVA tasks that we are developing for them to complete. So big project for us right now. A lot of cool things coming through it. Another one that this could be actually maybe relevant to the whole group is we are actually releasing a crowdsourcing campaign in the next week or so to essentially help generate a lot of content for Apache. So like I mentioned, we're a little bit limited on some of the EVA tasks that we have, and we're looking to expand a lot of that content to carry out a lot of the research that we're looking to do. So we are actually, this will be open to the publics, and I believe NASA employees can also partake in this, not on NASA time, but on your own time. So if anyone is interested, you can definitely download the editor and just basically just play around in what we've developed. And then if you want to participate in the challenge, we would love it as well. So I believe I have a couple minutes left, but this is kind of maybe I guess like a capstone for Apache. We're really just kind of kicking it off now. But it's the Persage project, the Personal EVA Informatics and Decision Support. So this is in collaboration with NASA Stennis's NPAS tool, which is an autonomous, the NASA platform for autonomous systems. So we are essentially integrating our labs. We have a crew state risk model that we are developing within our lab. And we're essentially trying to integrate that with Stennis's NPAS tool to sort of create an intelligent system to predict crew state, as well as then make operational decisions or recommendations based off of the predicted crew state. And just a quick example is if the crew is working too hard and they're burning the consumables faster than expected, this system would then notify either the IV crew or EV crew, or even make active decisions and actively change the operational tasks that are planned. So this is still very early in development, but we're looking to do like a proof of concept demonstration within Apache later this year. So just kind of summing everything up, this year really has been just a lot of development, trying to get a lot of the content and building up Apache so we can do a lot of this research that we have planned. So basically the future work is just to carry out a lot of this research. So a lot of subject testing, just a lot of testing coming up this year. So it's an exciting time right now to be in Apache, but yeah. And then just other stuff, like I mentioned, the Infinideck you see there pictured. That's a big thing for us, is to try to get that integrated into our sims and to do a similar analysis that we did with our passive treadmill. And then just further integration with the hybrid spacesuit simulator. And then, yeah, upgrading to Unreal Engine 5, where I don't know if anyone saw, they had the whole announcement, I believe it was yesterday. So that's now fully out there to the public. Oh, yeah, and then also, just because this is a XR Tim, just wanted to present a little bit of challenges that we've kind of been experiencing. One of those is just multi-room VR, particularly going throughout. We like to keep, I guess, a room scale VR environment within Apache. So looking at going through like airlocks and going through different doors out into a broader VR environment has presented some challenges. And then just the general infinite room walking challenge. Although the Infinideck is it's a commercial solution we've got right now, I think there's still some improvements that could be made to some of these commercial treadmill platforms. But right now it's a pretty good system. And then the wireless bandwidth limitations. So we do use the Vive Pro and we use the wireless adapters to allow us to like walk throughout the large space that we have. One of the issues we've been running into is we'd like to use the eye tracking plugins that we have from Frank's lab, and then some of the different finger tracking, like through a Leap Motion or even now through some of these newer headsets. But we've been having some issues of at least using both of those technologies at the same time. So that does it for me. I apologize about the videos. Hopefully we can get these charts shared with everyone. You can actually see we got some really cool videos and content to share. So
yeah, so Alex, you do have a couple of minutes left.
Okay.
If you want to look for any of the videos that you think would be interesting for the group. I'm tracking that you have 5 minutes.
All right, here's just a quick, so this is one of the cognitive tests that I mentioned. So this is the digit symbol substitution test. Essentially, the idea behind this is that during the walkback, we flash up this cognitive test. It lasts for 90 seconds. The whole idea behind it is that they see essentially a legend of number symbol pairs, and then they have like a test number symbol pair that is displayed to them in the yellow box. They're essentially supposed to answer whether they see the yellow highlighted pair. Does that match what they see in the legend? Then they just record whether it's true or false using the hand controllers. So this is just kind of testing a bunch of different visual scanning I forget all the different cognitive domains, not my area of expertise, but this is a pretty validated cognitive test, and just an example of some of the things that we will implement into the simulations we'll receive from Frank and others, basically adding on and modifying some of these to tailor some of our research questions. Here's just another video. So this is in the Mars scene, the 2-player scene. It's a quick video right now, but you actually will see there you got the 2 crew members. They've paused. One of them is now taking pictures and documenting their surroundings, but essentially just showing that 2-player ops in action. So we've been going through a lot of testing and iteration there to prepare for that Shapia analog, the Mars analog that the content will be used for. And then here is the Infinideck. So for those who are familiar, this is a commercial product. It is maybe one of the more expensive VR treadmills that you can buy on the market, but it's pretty impressive machine. You can walk in any direction. As you see here, essentially you just wear a waist mounted puck, and it just tries to keep you in the center of that ring. So we are still going through the process of integrating that into our sims, but it is it's made for virtual reality, and a lot of the support team from Infinideck is they're very supportive of helping us integrate this. So I'm sure they'd be very supportive of any future NASA collaborations. So I'm trying to think of other videos I didn't share. I think that was it. Yeah, so I saw the Infinideck, saw the different Mars. Yeah, those are all my videos I had to share. So,
Alrighty, well, thank you,
if
Alex.
there's any questions, I think we'll just give back to you guys now.
Alrighty, Alex, thank you. Was there a question online?
We do have a question for the links to the crowdsource. So we could actually post on the chat here for the crowdsource link.
Yes, so we're actually, I was probably doing maybe like a soft tease on that. We're actually releasing the crowdsourcing until maybe about a week from now. So when that does come out, we'll definitely have a lot of announcements and media attention surrounding that. So hopefully you'll see it then, but I'm sure we can share the link as well when it eventually kicks off.
Yeah, and Patrick just posted a comment on that. As Alex mentioned, we'll have our kickoff next week, and we'll provide the links to that.